Good morning, good afternoon, good evening, good night, depending on when you're watching this video. In this video, we are going to work through the exercise on constructing a normal probability plot, which is in lecture set 5 on slide 36. Okay, constructing a normal probability plot follows from our previous discussions on constructing a scatter plot. So a normal probability plot is essentially a coordinate grid where we line up the observation that we have observed with a value from the standard normal table, or a quantile of the standard normal curve, more specifically. Okay, so the way that this works is we will begin by ordering our observed data from smallest to largest. All right, so in part 1A, this is just an illustrative data set. So we have 6 observations, and we want to construct a normal probability plot for this data set, and then we'll assess normality using that plot. So in part 1A, we're going to take our observations, we'll call them X. Okay. And we are going to order them from smallest to largest. So the smallest value is 2.66. This is followed by 2.98. This is followed by 3.14. This is followed by 3.45. This is followed by 3.80. And this is followed by 12.56. Okay. All right, so now what we're going to have in the second column here are what we can call the normal scores. Okay, finding the normal scores is done using table 3. So table 3 has 2 pages associated with it. So this is page 1. You can see that the way the table works is it just provides you, or you locate the sample size that you are working with, and then you find your particular sample size and you take the column of data associated with that size. There are 2 pages, so this table ranges from sample size 5 to sample size 30. Now, in our particular problem, you can see very clearly here that we have 1, or maybe I'll just write them down here. So we have 1, 2, 3, 4, 5, 6 values. So this means that little n is equal to 6. So we go back to our table. We locate the column that corresponds to n is equal to 6. And what we are going to do is we are going to take these 6 values here, and we are going to line these 6 values up next to our ordered observations. So we have from table 3, negative 1.28, negative 0.64, negative 0.20, then we have 0.20, 0.64, 1.28. Now that we have our table of normal scores and our observed values, we can begin the construction of the scatter plot, which is the normal probability plot. All right, so we're going to draw 2 axes. Okay, something that looks like this. All right. It doesn't matter which axis has the observed value and which axis has the normal scores. For consistency, I'll put the values of x along the x-axis, and I'll put the values of the normal scores along the y-axis. Okay, now all we have to do is come up with a scale. In this situation, we'll start with a value of 2 on the x-axis, and then we'll increase by 2s, 4, 6, 8, 10, 12. All right, and then we'll come up with a similar scale here. So we'll have negative 1.5, negative 1.0. Just move my label over here. Negative 0.5, 0. I made my marking a little too big, so just move these down. 0.5, 1.0, 1.5. All right. So now all we have to do is we have to take each observation with its normal score and we have to mark it down on our axis. So for example, 2.66, so this is going to be 3. So 2.66 is right about here up to negative 1.28, which is right about there. So this is our first value. This is 2.66, negative 1.28, right? And then we'll take 2.90 right about there, mark that down with its value, which is going to be right about here. Okay. And then we'll take our next value, which is 3.14, mark it down with its quantity, which is going to be right about here. All right. So those are the examples of how the coordinates work. Okay, so then we'll have 3.45, which is right about there, with its quantity, which is right about here. All right. 3.80, 0.64. So this is going to be right about here. Yeah. Okay. And then 12.56, 1.28. Okay, so now we're going to be way over here somewhere. Okay, so now what we're going to do is we're going to determine whether or not the observations follow a straight line pattern. So in part B, what we can see is, or what we're asked is there evidence of normality for this population? Okay, so this is our normal probability plot. Okay. If we were to sketch a straight line through this data, so this outline point is going to pull the line over a bit. So this might look something like this. Maybe something, maybe something like this, for example. Okay, so you can see what's happening is the outlier is pulling the line towards it. But in this situation, what we can say is we can flag this, right, and say this is a potential outlier. And effectively what we can do here is we can say that since the relationship between the normal scores and the observed values is approximately linear, even with the presence of that outlying point, there is evidence that our variable of interest is approximately normal. If we were to ignore the outlier effect, for example, so suppose that the outlier didn't exist, you can see that these points very clearly follow a straight line pattern. So it's obvious that the bulk of the data is linear with the normal score. So that's evidence of normality. So as long as the observations and the normal scores form a linear relationship, that's what we're looking for in terms of assessing whether normality is present or assessing whether there's evidence for normality. But in this case, we have this outline point that's going to pull the line over, but it's again pretty obvious that if the outlier isn't there, those 5 main observations do follow the normal distribution, or that those 5 points are linear with the normal scores. And in this particular case, the probability plot is giving us evidence of one outlying point. So what we can say in conclusion is, since we observe a positive linear relationship between the observed values and the normal scores. There is evidence to suggest that the variable of interest is approximately normally distributed. Okay. Right. And then we could also make a note. So for example, note, we observe one potential outlier. All right, so in general, a normal probability plot, or rather in conclusion, a normal probability plot is a scatter plot between the ordered observed values and the normal scores that you take from table 3. Table 3 only depends on sample size. So you just count how many values you have, you find the column that corresponds to that number of observations, and then you build a scatter plot between the ordered values and those normal scores. If the scatter plot shows a linear relationship, and it'll be positive, a positive linear relationship, then there's evidence that the variable we are working with is approximately normal. If the scatter plot does not show a linear relationship, then there is no evidence that the variable is approximately normal. In situations like the one shown here, if the bulk of the observations appear to be linear, and then there's one value that appears to be far from that particular grouping, we can flag that as a potential outlier. While it's possible that this graph might be actually showing curvature, we can't determine it with the values that we are working with. We would need to collect more information. So given what we have, it's safe to say in this case, there is evidence that the variable is approximately normal and that there is one potential outlying point identified. Okay, if you have any questions, please let me know.